Okay, we are going through Moon as a world. So we have looked at the size and the distance and the motions. Remember those? Repetition daily. We have looked at missions. There are lots of missions in the book, and you want to be aware of the missions that led up to those Apollo missions, right? Watch YouTube, watch some of that stuff. They can be short clips. It's kind of fun to watch people jumping around on Moon. We'll talk about that. We looked at the origin. There were 3 ideas that were prominent. And then by analyzing all that stuff that brought back, we've got another idea, which is related. And now we're going to do moon layers. The interior, does it have a magnetosphere? Magnetosphere and an atmosphere. We can figure that out, and we'll look at it and see if that makes sense. The surface we'll talk about next time, and a feature by name. Okay, so there it is. So I really, really encourage you to get on the internet, look at moon pictures, you know, what's going on with moon, and step outside and look at moon pictures. Let's take a look here then and talk about moon. It's 4 layers. So we're going to talk about gravity. We're going to talk about the interior, magnetosphere, and atmosphere. And again, feel free to explore that. This is an outline for your study. So moon layer, Earth had 6 layers that we studied. What about moon? Let's take a look at good old gravity. And let's remember how important knowing the size of moon is. So that's what we've got to say right there. So you know, Earth is this big, moon is this big, shrunk to 1/4 as wide in each of the 3 dimensions, side to side, front to back, top to bottom, becomes that small. That means that there's a lot less matter there. And if there's a lot less matter, then you know that there's going to be a lot less gravity, because everybody, everything, every piece of matter has gravity, but less matter means less gravity. So a lot of people have this illusion that moon doesn't have any gravity, that there's no gravity on moon. Well, that's true. If you jump on moon, you just keep on going, Newton's first law, right? But you don't. You come back. We think of coming back as just what happens, but no. As we dig deeper into this, what we find is that there has to be a force to bring us back. Otherwise, we keep on going, Newton's first law, right? But on Moon's surface, it is less gravity, and we said it's 1/6 as strong as on Earth's. Not exactly, but very close, very close. That's very good. So on Earth, if you're wearing a 180-pound spacesuit, that includes the pack and everything, then you divide that by 6, and then you get 30 pounds. That's like 15 pounds in each hand. So it's doable. You're just not going to jump as high. You will ever return more slowly. If you watch those YouTube videos, you watch people jumping, they don't jump very high, but they come back down slowly and softly because they aren't pulled down as strongly, right? In fact, to orbit Moon in a spacecraft, whether it has people in it or not, to orbit Moon requires gravity, doesn't it? Because you can't orbit something, otherwise you go straight. You're not turning, you're not driving on a road where you can drive in a circle. You're allowing the gravitational pull to pull you in to that. So the gravitational pull is there to orbit anything, and jumping on the moon, as I say, is a different kind of experience. Take off that spacesuit, well, you'll die, unless you're in a room with the right temperature, right environment, right air pressure, right type of air, etc. And then that would be cool. As I mentioned before, you could jump 6 times higher. Very wild kind of experience. So it's fun to see them. Fun to see them drive their rovers, especially like Apollo 15, 16, 17, and you see a better video of that. So I encourage you to take a look at that. So yes, Moon has gravity, just not as much. Everything has gravity. Depends on how much stuff is there. Now let's look over here. That answer that question. Moon's interior. Okay. Here's the story. Cool. All right. Think about it, right? It's smaller. It's a smaller pot of coffee. It's a cup of coffee and a pot of coffee. It's got less hot stuff inside. So it's cooled much more than Earth. Small cools faster, 2 reasons. Less hot stuff inside and less radioactive stuff inside, right? Because there's just less stuff. Okay, cool. So small iron core. I'm going to have you just explore. If I'd say this, just look it up. But look for recent numbers that people believe from other missions, not just the Apollo. We've done a lot of missions. People have done a lot of missions since then and really measured the gravity variation. So how big do we think that iron core is? Remember why we think there's iron in the center? Well, we know for a variety of reasons, but as something forms, it's hot, liquid rock, liquid metal, and the hot, dense stuff like iron will sink to the center, right? So iron and nickel, just similar to Earth's construction, and then around that you're going to have rock, a rocky mantle. So possibly a little liquid iron, and mostly, let's see, what do I want to put that in? Mostly a cooled mantle. Let's make that note over here. Mostly cooled rock mantle. And it's a large mantle. In fact, Moon is almost all mantle. Take a look. You'll see images. Google images, whatever you want. NASA, of course, is great. And take a look at some of those pictures. Now, I could put color pictures in the book, but it becomes much more expensive. So, and also explore this on your own. Think about the connection of the layers. Oh, Moon's small. Oh, so it's going to have cooled inside. Maybe there's a little liquid iron, maybe there's some radioactivity that's keeping things liquid and warm in certain regions, but it's mostly, basically, a dead rock, right? With a little iron core in the center, but mostly it's a dead rock. And a bit of iron on the surface, but it's mostly a dead rock, okay? All right, cool. Now, what else can we deduce from the size, knowing the size of the Moon? And of course, we can deduce something, but if you go and measure it and you're surprised, well, that's interesting too. Let's talk about the magnetosphere. Okay, magnetosphere, what do we know? Think about it. Pause and see if you can guess. Think about what you know about magnetosphere. Got it? Okay. What about the core or the mantle? So it's got a small iron core. Remember where our magnetosphere comes from? Our liquid iron core. I'll say mostly solid. You could even say entirely solid. I mean, it's a small point, and you can look that up. Mostly are all solid. And another point, right? What else gives us our magnetism? The spin of Earth. We spin once every 24 hours, fairly rapidly. So we're going to see that. So Moon, and you know about moons. Moon, capital, moons. Let me say it this way. Moon spins slowly, right? 28 days, about 28 days. Synchronous spin orbit, about 28 days. So it's got a slow spin and mostly, if not all, solid core. Is that going to give you magnetism? It's missing those 2 ingredients, right? And so that's the way we're going to think about this stuff. Now, in the past, you can go and take measurements, whether it's people or stuff we bring back or unpeopled missions. Then in the past, you find that yes, because it was hotter, It was going to have some liquid iron. It was spinning faster. Yes. More than now. This is a common theme as we study worlds. It was hot. What about now? No, it's cooled. Little to none. It has cooled and got the slow spin. That's the story for magnetosphere. Wait! There's some interesting implication here, important implication. If it doesn't have a magnetic field, what do you not have protection from? What do you not have protection from? Clear this. Finishing up this chapter. Make some space over here. Make sure you can see it. You have no protection from, you got it. You've got it. What does it protect Earth from? No protection. That's Moon's surface, or if you're on the surface, you need protection. It's very doable, but no protection from solar wind. Critical. Okay? So the solar wind comes in. Remember, that's not the light the sun sends out. Little bits of matter, mostly protons, electrons, that hit the surface. So that's important. Now let's talk about atmosphere. Does it have an atmosphere? Well, there's your answer. You can pause. You can listen to me talk about it. Explore it. And these are the main layers, right? We've got the interior. Now we're going to talk about the surface next, okay? Then we got an atmosphere. Well, let's see. What do you need for an atmosphere? This is key. Make sure you know this. Then you can think about Mars. You can think about Venus. You can think about Mercury. You can think about other moons. Atmosphere requires gas from a warm interior. So the gas comes from inside, that volcanism. Remember that? It comes from inside, but maybe it was releasing before. Not so much now, right? It's not releasing that gas, not so much, if any, right? Maybe bits, and maybe they'll talk about little bits of this and that's interesting in detail when you're getting into it. So that's the good work of an astronomer. You need enough gravity to hold the gas. Even if it's releasing gas, you've got to have enough gravity. And there's gravity, but it's still 1/6, so it's not very much. Maybe it could hold gas, but then also you need the surface to be not too hot. Not too hot. Sorry. Not too hot. How far is Moon from Sun? Well, it's right next to us. It's almost part of it. It's our backyard. So remember that effectively, Moon is 1 AU from Sun. Sometimes on the new moon, a little bit closer to Sun, full moon, a little bit farther, but it's 1 AU. So in terms of being too hot from Sun, it's the same distance from Sun as Earth is. So that seems to be kind of okay, but not much gravity, not releasing warm interior. So make sure you can explain that, say on an essay question. Basically, there's no atmosphere except dust kicked up by what? The solar wind can kick up some dust. So you can hear some discussion of this and that. If you get into the detail of this, we're getting the essence right now, and then you get into the fine details, and that's where you do the science and etc. Okay, so very, 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 very important. So important, I'm going to use red. Okay, if you don't have a magnetosphere, you don't have protection from solar wind. It's going to come in and hit the surface, and it's going to hit whatever is there. All worlds without an atmosphere now have no protection from what? Find the right color. Although it's not a color because it's not visible light. UV, ultraviolet light, Remember, Earth's stratosphere has the ozone to absorb ultraviolet light, block it. So you don't have an atmosphere to block that, so the UV's hitting the surface, sterilizing the surface, if you will, if there was anything to sterilize. And there's also no greenhouse gas. Earth has that in the troposphere, right? The greenhouse gases like carbon dioxide and methane, water vapor as well, things like that. So if you don't have a greenhouse, if you don't have a blanket, if you don't have a greenhouse gas blanket, well, in the sunlight, then nothing gets blocked. All of that sunlight hits, and it's gonna bake, right? Nothing, it's like no shield there. So in the sunlight, it's very hot, but when you go out of the sunlight, you've got no blanket, and you quickly get very cold. And so you see these extremes on any world without an atmosphere. And now we've seen two very different worlds, Earth and Moon. Similarity, you know where Moon came from, similarity with an iron core, rocky mantle, sort of a crust, right? Same physics, same ideas, and yet because of that size, now, very, very different worlds. Okay, let's talk about what's on the surface of Moon. And you've got it.